This hinge worked perfectly in Basswood, so I ran the exact same file in Maple on my xTool S1, and it snapped almost instantly. I could redesign it from experience, but instead I asked AI how to fix it. I'm Mick. This is Limey Cottage Crafts, where AI meets the workshop. And together we discover what actually works. Basswood is soft and forgiving. The fibres bend. Maple is denser, more brittle, and far less tolerant of sharp internal stress points. The hinge slots were too wide, the internal corners were sharp, and the structure wasn't designed for hardwood. So let's see what AI thinks. The initial response highlights the differences between the basswood and maple, and handling these woods you can feel the difference, but it is good to understand why this is. I like the analogy of comparing cardboard to acrylic. The heat build-up in maple was not something I had previously considered, nor was the importance of grain direction, although the breaks I had witnessed reinforced the parallel grain. I had taken a simple slot design to form the hinges, and the feedback suggests this may be the problem. Again, my experience of handling the maple hinge was of a stiffer bend. The suggestions include tweaking the geometry, orientating the hinge to the grain, adjusting laser settings, conditioning the wood. The comment around applying the bend works for me, but I have to consider customer who I know from experience treat this as if it were a normal card and open it quickly. I think this final point is worth reading in full. A useful mental model. A laser living hinge isn't really a hinge, it's a controlled failure zone. Basswood fails slowly and elastically. Maple fails suddenly. Your goal is to redesign the pattern so maple reaches its bend limit after your intended shape, not before. That's reasonable advice, but advice is cheap. Let's test it. This hinge isn't decorative, it's structural. It holds this memorial card open so it can stand on a shelf as a permanent reminder for a family. That means it has to feel smooth and survive repeated bending. I'm using a 40-watt xTool S1 and testing two materials, solid maple measured at 3.5mm and basswood ply measured at 2.8. I tested 3 centre-to-centre pitches, each one cut in, parallel grain, perpendicular grain, and 45 degrees. Slot length was 57mm, slot width was 0.7mm, staggered capsule pattern, everything labelled, everything controlled, and yes, quick confession, I initially mislabelled pitch in Illustrator because distribute spacing works from the edges, not the centres. That's now corrected. Maple behaves beautifully until it doesn't. It feels premium, it feels engineered. But it only tolerates about 30 to 45 degrees of flex before stress builds quickly. The closer pitches, especially 2.3 and 2.6, felt smoother and survived initial testing. The wider pitches felt stiffer and were more likely to crack. And here's the key insight. Every failure happened in the same place, where only 2 ligaments carry the bending load. That's not a pitch problem, that's a geometry problem. The 45-degree orientation was actually stronger. It spread strain across the fibres. But here's the problem. I can't get maple wide enough to manufacture the card at 45 degrees. Engineering isn't just about optimization, it's about manufacturability. Basswood behaves completely differently. It bends to 90 degrees easily. It feels smoother. It tolerates variation in pitch far better than maple. Only one configuration failed, 45 degrees at 2.7 millimeters. That's like laminate behavior versus solid hardwood behavior. So here's the current production standard. For solid maple, parallel grain, 2.3mm centre pitch, 0.7mm slot width. For basswood, 2.4mm pitch as a balanced default, 2.1 if maximum flexibility is required. Maple feels premium. Basswood is mechanically forgiving. The real insight wasn't the pitch, it was this failure zone, where only 2 ligaments connect. That's where stress concentrates. So in the next episode, I'm not adjusting pitch, I'm redesigning the ligament geometry itself. So can AI fix a snapped living hinge? It can help, but it still needs a maker to test it. Most CNC and laser creators optimize known methods. I'm trying to experimentally validate what's actually possible, especially when AI suggests designs. If you want the full documented results, you can find the link below. And next time, we redesign the weak point.